And then we've got guys in the UK and Amsterdam.
And Argentina and South Africa.
That's right, yeah.
So DApp, decentralized.
Decentralized organization. I think we have one more question.
Bring it on.
Hi, I'm Zvi. I'm a guest here today. I'm from Kiva, where they did microloans. And it's sort of a monolithic platform right now, and so I'm pretty excited to learn more about how you engineer the software to be modular and not have single points of failure. And I'm a little bit new to some of the technologies, but I would definitely love to play around with your toolkit, and will email you.
Did you catch that?
Yeah, I don't think I caught a question. That sounds really great.
I'll probably continue offline, but the question was, do you think that Go as a software ecosystem is the right place to be building tools for this stuff?
And the single point of failure.
And the single point of failure issue, like, do you think that having multiple implementations is also a way of avoiding single point of failure?
Yeah, right. Yeah, okay, this is a great question. And it's a super hard one to address, really. So wait, just to be clear, you asked about Go, like our use of the programming language?
Yes.
Yes.
Or did I miss that? Or misunderstand that? Well, I'll just pretend that is what you said.
Yes, it would.
Go ahead.
As far as
Sorry, I was going to say, would you recommend Go as the place to start hacking to get into this ecosystem? I have a background in PHP and Python and other stuff, but Go seems like it's a really kind of viral, powerful platform.
Yeah, totally. So yeah, I really would. Go makes writing concurrent programs probably easier than, and definitely any of the languages you mentioned, and probably many others. The way I like to describe Go, sort of the way I saw it described more on the internet once, is if the guys who built C had a chance to rewrite C after writing in Python for a decade on Google-sized architecture, they would build us Go. And that's more or less what happened. And we're seeing a lot of really nice tools being built in Go. The main Ethereum clients in Go, the IPFS client, is being built in Go. Tendermint, which is another, sort of the most promising proposal right now for a proof of stake chain, is being written in Go. A lot of people are reporting outstanding results moving their sort of web server infrastructure to Go from Ruby or Python or whatever. If anything like memory footprint or speed are concerns to you, I think Go is probably a great place to be. Some people are still concerned because it's still really young. I mean, it's basically as old as Bitcoin now, which is a funny way to look at it. But it's supported by Google, as opposed to a couple of developers supporting Bitcoin. So I think having sort of Google support behind it is pretty powerful, and I think it's a really good place to be. Now, at the same time, if there's a little tiny bug in Go, that could bring down the entire ecosystem. So obviously we want all implementations. Really the place I want to get to, and the problem I have with the current sort of blockchain infrastructure setup is that, the multi-client thing is great. I mean, we're running a full node here. It's a BTCD, is the Go client of Bitcoin actually, which was written about a year ago, I think, and is pretty stable. And it runs really well. Of course, the problem is there's no way to actually verify that implementations are going to produce the same results, especially not for something as complex as these consensus systems. So I've seen Peter Todd sort of rebel against the fact that there are all these alternate Bitcoin implementations because we need to focus our efforts on making sure that the standard implementation works with itself and is free of any kind of consensus bugs. But in the meantime, the alternative implementations can help reveal those consensus bugs, and it's probably a really good thing to have. What I would like to see us move towards, the position where all the actual consensus logic is written in a higher level language or a higher level scripting language that has a standard. So, you know, like if the blockchain communities could come together and put out a spec for which consensus rules should be written, and then different developers can be free to implement that spec, which is more like a virtual machine than a consensus mechanism. And then we only need one implementation of the consensus mechanism, which runs in this, you know, script language we've defined. And then there can be many implementations of the virtual machine and the P2P layer underneath it. But that way, you know, writing a new blockchain client isn't writing the whole client and all the consensus rules. It's just writing sort of the virtual machine and peer-to-peer layer, and everyone would just use the same sort of, you know, official reference script to run within their different implementations. And so I think if we can get towards that kind of situation, we'll be a little more stable and a little more robust and a little more safe from like crazy forking and so on. But this is like a very, very difficult problem, and is probably sort of, brought to light afresh by the challenges of blockchains and all the kinds of crazy little things that could go wrong to cause a consensus fork. So it's definitely something to worry about. We're probably just going to stick with our Go implementations and that sort of ecosystem for now. But we are moving towards, you know, defining a virtual machine and implementing that virtual machine and then writing the consensus rules for a blockchain once. And every different implementation of the virtual machine can run that same script. And I suspect it's probably a lot easier to formally verify the implementation of a virtual machine than it is, you know, the implementation of a full consensus mechanism. And those are some of the reasons why I favor that kind of a model. But yeah, it's definitely a tough question. It's something always on my mind.
Yeah, it's very stimulating, the idea. Like, it makes me think like, oh, could you embed a test suite in a blockchain? And then people's like, you know, and then the implementation and then the runtime engine of the consensus engine is pluggable.
Yeah, so there are. You said there.
This may be the subject of a longer conversation. Did you hear what I said?
Bitcoin, there's a suite of sort of consensus tests that try and test as many of the edge cases as possible. The idea is, you know, if you're implementing a new Bitcoin client, you at the very least have to pass all those tests, but, you know, those tests aren't enough, and we don't have any kind of formal verification of these software suites and these stacks, and there's so many layers of execution from, you know, everything the operating system introduces and then the programming language runtime and everything on top, that at the end of the day, I'm almost hoping that we end up with like implementations and hardware, and then we can just put it all behind us. But even still, that probably won't solve the whole problem. So we're gonna be battling with this issue for a long time, and the best we can do is have very strong networks of support by the developers, so that if and when there is a fork, we can detect it, you know, as quickly as possible. Actually, something that one of the developers of this BTCD, the Go implementation of Bitcoin, he wrote a great blog article about this a few weeks back. It's called "The Red Herring in Bitcoin," something like this. You should be able to Google it. He basically talks, you know, the reference client isn't even always,
You're breaking up a little bit.
Consensus with or consensus compatible with itself in older versions. I mean, if you look at the Bitcoin fork from about how last year, that was the same version being incompatible because it changed to dependency, and, you know, no one expected that fork to happen, even though they tested all kinds of cases and so on. So what he recommends in that blog post is that the miners actually start running multiple implementations of the software, and so that the mining node runs all transactions and blocks through like 3 or 4 different implementations. And so if there's a hiccup in any of them, they can catch it right away and immediately tell everyone else about it, possibly before the fork even propagates. So, you know, that's putting more cost on the miners, and obviously things are hard enough for them as it is right now. But moving forward, that's probably a really good practice to try and nurture and have everyone follow. But easier said than done.
Thank you.
Anyways, it was a really good blog article, and there's sort of an ongoing debate between the guy heading BTCD and the reference Bitcoin guys on whether or not the alternate clients are a good thing. I'm running the alternate client; it's working fine for me. It took a while to catch up, but it's on an old machine, so I'll let you guys know if there's any forks. Yeah.
Well, thanks again, guys, and we'll catch you later.
Thank you.
Cheers.
Thanks.
Thanks, guys.